working on page 9 of the 5.6 notes. We had done the first problem on it on the last video, so we're getting ready to start the second one, number 4. So again, one of the comments is, how do you know this is going to be a proportion? And it's really pretty easy to see. Lines, seconds, lines. This says minute, but that can easily be changed into seconds, right? So lines, seconds, lines per minute would be 60 seconds. So we can just put that in. So that's how you know it's a proportion if they don't tell you in the directions. Sometimes the teachers will tell you, sometimes they won't. But you just see the common labels repeated in each part of the problem. So then I know to come over here and write lines and seconds. Because remember, when I write my proportion, I have to be consistent. So 177 lines, 3 seconds. And one of the questions I get at this point when we're in class is students go, could I write seconds over lines? Absolutely. All that matters is that you're consistent. If lines is on top here, lines have to be on top here. If seconds is on top, just make sure it is on both. But you definitely want to write it for 2 reasons. One, to stay consistent, because the problem doesn't always give it to you in the right order. Second reason is just like we found up here, once you find X, then you don't have to reread the problem and decide what the label is. It's on the centimeter side, so you just put centimeters. And the third thing we learned from up here was we never round. We give exact answers unless otherwise directed. So here it says how many lines. So on the line side, I put X, and it says per minute. 1 minute is 60 seconds. And so let's do LCD this time, since we did setting the cross products equal there. So LCD. 3 and 60 both go into 60, right? So I could multiply this side by 60 and this side by 60. So we see 3 goes into 60 20 times. And here 60 divided by 60 is 1. So we get X equals, what's left over here, 177 times 20. So type that in your calculator and you're done. So 3 and 60, common denominator 60. They both go into 60. Multiply both sides by 60. Here they cancel. Here the denominator canceled. 3 goes into 3 once. 3 goes into 60 20 times. So that leaves 20 times 177 over there and X over here. And then we type in 177 times 20. And we get 3540, so 3,540. And remember, every word problem needs a label, and sometimes you'll be asked to do sentences too. So I look here and say the X is lines. So if they don't ask you for a sentence, you just write the answer with lines. If they did ask you for a sentence, you'd say in 60 seconds or 1 minute. The computer can print 3,540 lines. Okay, couple more. And we have one of these on the test. Which one should we highlight? Let's do, I know there's decimals on the test, so let's do 5. 6 has fractions, 5 has decimals, so we'll do 5. So there's one of these, then there's one with triangles like below. Okay, so we have 7 Cuban sandwich rolls, cost $8.54. How much will 15 rolls cost? So rolls, cost, rolls, cost. So that tells me to set up my proportion because I have the same units repeated in each part of the sentence. So rolls would be 7, cost would be $8.54. Then it says, how much will 15 rolls cost? So how much will they cost means put your X down there. 15 rolls, 15 up here. So now we can see that we have our proportion. In this one, I think it would be easier to do the set your cross products equal, just because the LCD is going to be a decimal. So let's do this. 7 times X equals, set it equal to this cross product, $8.54 times 15. So again, we turn to the calculator. So 8.54 times 15 is 128 1/10. And then we solve just like a regular algebra equation. Divide both sides by 7, and we get X equals, and I can see X's cost, so I'm going to get my dollar sign ready. And we know 7 cost $8, so 15 should cost about twice that, $8.50 and $8.50, so a little over 17, I think. So let's see, because I always like to kind of know what my answer should look like before I type it in the calculator. That way I'll know if I've made a mistake. So 128.1 divided by 7. Yep, a bit over, what did we say? A bit over $17. Yep, $18. And if you type that in on Alex, or if you write that on my test, I will count it wrong. That's not how we write money. And Alex knows that's not how you write money either. So you need to make sure you write it as money, which would be $18.30. But if you just type the 0.3, you will not get credit. So be careful with that. That's why it's always good to have these labels so you know what it is you're finding. Because if I wouldn't have known it was money, how would I have known to put a 0 on it? But because it's money, that's how I knew to add a 0 to the decimal. So $18.30. So if they asked you to write a sentence, you would say 15 rolls cost $18.30. Okay, it's your turn. So like I said, the one on the test has decimals. This one has fractions, same diff. So go ahead and work number 6 and then come back and we'll check it together. So first we want to see what it is we're comparing. So we are comparing water to cups of mix. So cups of water, cups of mix. So we should use the units. So cups of water, cups of mix. Why be that specific? Because if the answer needs cups on it, you have to know that. So, and you also have to know whether you're putting water on top or the mix on top. So you do need to be specific. This is the units, and this tells you what quantity we have up there. So it says 3/4 cup of water for 1 cup of mix. How much water, so that immediately says go to the water side and put X, need to be added to 3 cups of mix. So this one's definitely easiest to do the cross products, because see how you have the 1 in front of the X? So doing the cross products, we get 1 times X, which is just X, equals, this cross product would be 3/4 times 3, which we can easily do in our calculator. So X equals, so 3 fraction bar 4 times 3, which is 2 1/4. And usually on problems like this, they're going to ask for a mixed number, because if you write 9/4, do you ever read a recipe and it says, oh, put 9/4 cups of water in there? No, usually doesn't. So Alex is going to be probably more common sense and go, okay, well, write your answer as a mixed number. So be sure and read the directions. Does it want a fraction? 9/4. Does it want a mixed number? 2 1/4. Does it want a decimal? 2.25. So you don't want to do all this problem and then miss it because you put the answer in the wrong units. So this doesn't say. So when it doesn't say, I just try to keep the units consistent. Since a fraction was used, I'm going to answer it with a mixed number, but I'm not going to put a fraction here and then a decimal answer unless they ask, because they say keep your units specific. So this would be 2 1/4. Then I look at my proportion. X is on the side of cups of water. And if they asked for a sentence, which they do occasionally, you would say 3 cups of mix requires 2 1/4 cups of water. And there you have it. Okay, so that's the proportion with the real life problems. Next, we're going to do proportions with geometry problems, and I put one of each on. I put one real life one. I think it seems like it was calories and something. I don't know. You eat so many of these, it's blank calories. How many calories for this many? It seems like it was that kind of problem. So this is a very good one. Any of these three are a good one to study. I just kind of remember it having decimals, so that's why I chose that one. Okay, so the next section, we're going to be doing the same thing. It's just now we're going to be doing it with triangles. I'm sure most of you took geometry in high school, and you may or may not remember some of these, but one of the theorems you learned in geometry is that the sides of similar triangles are proportional. So similar means, just to refresh your memory, one is just a smaller version of the other. Kind of like when you make a model car. You know, it's a smaller version of a regular car, or a model airplane's a smaller version of a regular airplane. That's what similar triangles are. One's a smaller version of the other. And its corresponding sides are proportional. The angles are actually equal. So angle A is equal to angle X, which isn't a part of this problem, but just, to give you all the background. So corresponding sides are proportional, which means we can write them as a fraction, but corresponding angles are actually equal. So I know these two angles are equal, these two angles are equal, and angle C and angle Z are equal. And a lot of students are like, well, how can they be equal? We'll set a protractor down on them and you'll see. It has nothing to do with size of the triangle. This triangle's angles add to 180, and this triangle's angles add to 180. So shrinking a triangle does not shrink the angle. The angles stay the same size. It's the sides of the triangles that change. So we first have to do corresponding. So we have to figure out what corresponding is. So corresponding means they're in the same location. So A corresponds with X. C corresponds with Z. And last but not least, B corresponds with Y. Because you have to know what corresponding sides are. That means they're in the same place on the other triangle. So you could never match C up with X, for instance. So the corresponding means they have to be in the same place, base to base, left side to left side, right side to right side. So what we have here is A corresponds with X, so A over X equals B corresponds with Y, so B over Y equals C corresponds with C, C over Z. So A goes with X, C with Z, B with Y. And we keep them in the same order. The left triangles are